Hello, Java hipsters. My name is Matt Rabel. Today, I'd like to show you how to take a reactive microservices architecture built with Spring Boot and JHipster and deploy it using Kubernetes. I'll show you both how to do it on Minikube locally and to Google Cloud with its Kubernetes engine. Let's giddy up. This screencast is based on a blog post I published a couple months ago, and I recently updated after queuing it and make sure everything works, so this screencast shouldn't have any flaws in it unless I copy and paste something wrong, but we'll work through those as they happen. At the bottom of this, if you clicked on this last updated, you'll see there's a GitHub repo right here. I have that open in this window, and there's a demo.adoc file. So adoc for ASCII doc, if I were to view the raw version, I have a handy dandy ASCII Doctor plugin that formats it nicely. This demo script is just a condensed version of the blog post. It has all the same steps, all the same code snippets, and all that kind of stuff. And if you want to learn more about Kubernetes and Spring Boot and JHipster, what I'd suggest is reading the blog post because it's got a lot more content in there. I'm just going to show you how everything works using this demo script. So I'll put that on the left there, and we'll start with creating Kubernetes deployment descriptors. JHipster will do this for you, so you don't need to write a bunch of YAML by hand. It will actually generate all those for the different microservice architecture you have. So I'm going to start by cloning a GitHub repo right here. We'll just do that in my home directory. And then I did skip a bit up here at the top, the prerequisites. Let's make sure I have Java 11 installed and Node 14 and Docker. And Google Cloud, I do have a Google Cloud account, so I won't be setting that up. And then JHipster, so I do have JHipster installed. And just to make sure I'm not using like a nightly build or the nightly branch, I will go ahead and install it just like it says to here, generator JHipster 7. All right, so everything that I need to do this screencast is installed, and we'll get started. So the first thing you're going to want to do is create a K8s directory. So you can do it the old-fashioned way with K8s and then, cd into it, but I like the take command. That's part of omyzsh. It creates a directory, cd's into it, pretty slick. And then we can run JHipster K8s. And so it prompts you what type of application would you like to deploy, microservice application. And all of our projects are one level up from this. There's a blog, a gateway, and a store. And a gateway is Spring Cloud Gateway that actually has, just routing rules and things like that and access to the microservices. And then the microservices, there's a blog microservice and a store microservice. So we'll go ahead and select all of those. As far as monitoring, we'll say no, just to keep things simple. Cluster database, since we're using MongoDB for the store, I will say we want to cluster those. For the blog, we're using Neo4j, and for the actual gateway, we're using Postgres, and Postgres uses R2DBC for its reactive database access. And then the admin password, what I'm going to do here is I'm going to use JShell and do UUID random UUID. Because that's, a pretty good password in my opinion. So we'll just copy that and exit out of there and paste it there. And then Kubernetes namespace, you can use the default, but a lot of people don't use the default. They have their own, so I'm going to have my own with demo. And then base Docker repository name is your account on Docker Hub. I have a Docker Hub account, and I will push things up to Docker Hub during this. So mine's mrabel. Docker push is just fine. Enable Istio, no, we just want to keep it simple. Kubernetes service type, we'll do load balancer. And then dynamic storage provisioning for your stateful services, we'll say yes, and just leave that blank. And so you'll see what happens up here is it warns us, hey, there's no, blog, gateway, or store Docker images, so you need to create those. And then it creates a whole bunch of YAML files. So you don't have to. That's pretty nice, right? And so using Jib, we can create those Docker images. So we'll go down here. I'm going to skip this Minikube step because we can do that while we're creating our Docker images. So we'll go into the gateway and we'll create that Docker image, and then we can do them all in parallel. It doesn't really matter, right? Just got to make sure you're in the right directory. So cd into blog, and then change this to blog, and then we'll do another one for store. Okay, so we have all those Docker images getting created, and I am screen recording this using Camtasia. So what I've noticed is it does slow down probably 50%. So even though it says, it took a minute, normally it would only take 30 seconds. The gateway does take a bit longer because it is doing npm install and it is doing TypeScript compilation. So The others should be pretty fast, but while we're doing that, we'll start up Minikube. So Minikube CPUs 8. And the reason I do that is the default is 2, and that's just not enough to run this microservices architecture, and then start. And so if you don't have Minikube installed, you can use brew install Minikube on Mac, on Linux, and other ones. You might want to check out these installation instructions here and go ahead and navigate to that site and install Minikube that way. All right, so Minikube is started, so we can exit out of there, and all of our Docker containers have been created, so we'll exit out of those as well. And then the next thing I want to do is configure JHipster to use Okta for authentication. By default, it uses Keycloak, and we populate the users, the realms, and all that stuff, so everything's set up for you with Keycloak, and it runs in Docker. When we generate the Kubernetes files, though, we don't generate Keycloak files. The reason for that is we don't really want to populate a Keycloak instance for your production with all that default data. And so no one's really taken the time to make Keycloak work with Kubernetes. I'm sure it's possible, but for right now, it's just easier to use Okta. And so I'll go into this K8s directory and use the Okta CLI. So I already have that installed, Okta version there. If you don't have it installed, you can go to cli.okta.com, and whatever OS you're using, it'll default to those instructions and show you how to use it. I already have it installed, and we will run Okta apps create JHipster. So the Okta CLI has built-in support for JHipster, and it knows what to do. So we'll just call it K8s. That's fine. Common defaults for especially microservices architecture is it uses, these URLs here, 8080 for the gateway, login OAuth 2 code /OIDC. If you're familiar with Spring Security and you've used it with Okta, the suffix at the very end is Okta instead of OIDC, but we use the same configuration for Keycloak and Okta. That's why we just chose the OIDC suffix there. And then this 8761 is for the JHipster registry, which we will also secure with OIDC. Select those defaults, and then use those same post logout redirect URIs, and it'll create a new OIDC application on Okta. It'll also do a couple other things. First, there's our client ID. It'll create a groups claim that has your groups that you're a part of on Okta. So you see it created 2 groups, role user, role admin, and it added my user into those. So that will give all the permissions that JHipster expects and controls, based on those groups. So it puts it all in this okta.env file. You can see all we're doing is overriding the Spring Security configuration that's configured for Keycloak to use Okta. So it's pretty slick how Spring Security makes it, so we can do that and just change a few properties. Because we're going to run in Kubernetes, we're going to use JHipster Registry, which has Spring Cloud config in it, to distribute the configuration to all the microservices and the gateway. So we just need to grab this code here to put into there. So we'll go ahead and open it up in an IDE. So the file you want to modify is in this K8s registry K8s directory and this application config map. So it just has a bunch of default configuration in there that you will need to have everything running in Kubernetes. And then we're just going to add a new set of properties here. So you'll see it is YAML and the indent's a little off, so we got to back things up a little bit, and then that should work. And then we'll grab those values out of the okta.env file. So that's right here. And we can just grab this domain here to start, and then Command E to switch between files. And so we'll do right there. Okay, so now we have all our Okta settings in our application configuration for all our microservices. This will be distributed by Spring Cloud Config. But you might be wondering, that's a client secret. That shouldn't be put into files that might get checked into source control. And you're absolutely right. So we will fix that as we go along. But for now, I just want to show you everything running locally with Kubernetes. So the other thing we're going to want to do is configure this JHipster registry to use the OAuth 2 profile, and now we can start everything. So in the K8s directory, run this command, kubectl apply. So we'll just look at that. It's basically a bash script that, runs it for all the different namespace, the registry, all that kind of stuff. So run that. Oh, need to be in the right directory. K8s kubectl apply -f. So it created all that namespace for us. Now we can go back to our terminal here. And we can watch it with kubectl get pods, and then the namespace is demo. and you can see it creates those. They're starting. There's another sweet tool, K9s, from my good friend Fernand Guliana, that allows you to actually watch them, start up. So you could go to this JHipster registry, and you could actually see the log files. So, you can watch it start, which makes it a little easier rather than, using kubectl and, issuing a log command. So I do like K9s for this. So once you see everything started up, you can escape out and Control C out of there. And then we can do some port forwarding. So this is how to port forward from that JHipster registry service onto local host 8761. And then we'll do one for the gateway as well. Oh, that one's not running yet. So let's do K9s-n demo and just check out the gateway, see where that's at. Maybe we need to make this a bit bigger here. Gateway, it's still initializing. So that one's not quite ready, but we can go ahead and look at 8761. So it automatically redirects you to log in, and it populates with my credentials right there. That was just my browser remembering my credentials, right? I didn't do anything else there. And everything else is still starting up. So you can see the gateway's just starting. I believe this happened because before I did the screencast, I cleared out all my local Docker images. So there was probably, some things I had to download to make all this happen. So just takes a little bit to start up, but as long as you're monitoring and watching it, then you don't have to, be like, why isn't this working? So now our gateway's up, so we can close this. And then if we refresh over here, we see the gateway there. And if we were to go to localhost 8080, oh, we didn't do the port forwarding. So back to our instructions here, port forward for that gateway. Now localhost 8080. There's our gateway, and if we sign in, well, we're already signed in, right? That is the beauty of single sign-on with Okta. Even though we're accessing two different ports, 8761 and 8080, Okta has our session intact on its server, so when we go to log in there, it knows that we're already logged in. And let's look at the registry again. Refresh. So we got the blog and the gateway. The store is having some issues starting up there, but we can look at the blog, and we could create a new blog, call it Matt's blog. And that's all working. This is using a Vue front end, so JHipster supports Angular, Reactor, Vue. This happens to be Vue. And I'm not sure why our store isn't starting locally, but it worked yesterday when I tried it, so I'm sure it'll work for you. And when we get it up to Google Cloud, hopefully it'll work there as well. So the next thing I wanted to tell you is that we have Cypress involved in these tests. So if we wanted to run E2E tests, you could go into the gateway directory and you would export your Cypress username, E2E username, with your Okta username and then the password, and then you could run it and it would talk to Okta to do all your E2E tests. So that's pretty handy to be able to run and know that everything as far as your application is concerned is functioning. I'm not going to do that because that takes about 5 minutes and it's kind of boring to watch, but last time I tried it did work. So the next thing we want to do is JHipster Registry has an encryption feature. So you can encrypt properties in your Spring Cloud configuration and then check those into source control because they're encrypted. So you just have to remember the encrypt key. So you can add this environment variable in the K8's registry, JHipster registry, and that'll work just fine. So let's do that. So under the environment variables here, we'll go ahead and add a new one. And again, make sure you get your YAML indents right or nothing will work. And then we could do JShell down here and UUID random UUID. And so we have another good password or good encrypt key. And exit out of there. And since we've updated that YAML file, now we need to kubectl to apply it. And you'll see most things are unchanged, but this JHipster registry is reconfigured. And so if we were to open it up, localhost 8761, and go to this configuration encryption, what we can do is we can grab that client secret and encrypt it so we can store it safely in source control. It looks like it's down, right? It's restarting. So try it again here. Try resetting our port forwarding. I'm not sure what happened there, but now it's all working, and I didn't really restart anything, and it just took a while to get to this state. So now we're back up, and if we go to the encryption setting, we have that client secret. We can encrypt it, and then you'll see we get a whole new encrypted version of it. So we can go right here. There we go, and change that to this value. Now, one of the things I've noticed is you do have to put it in quotes. And if you don't, it won't quite work as you expect it to. And make sure you have it all in one line. Let's see, make sure that, yep, it just wraps, right? So everything's working, that's in there. And then we can go back to our instructions here. And you'll notice it says, put that encrypted client secret in there and restart it again. And so again, we will change our JHipster registry. You'll see it's configured right there, that stateful set, and then we can restart all the deployments because we'll want them to pick up, that new configuration. It restarted the blog, the gateway, Postgres, and the store. There is a way with Spring Cloud Config to refresh the configuration and have the microservices pick it up. So that's in a different post. Oh, what am I doing? I'm linking to the wrong one. So developer.okta.com. Spring Cloud Config is the name of the post, and sharing your microservices configuration between them. I do have a screencast about this Spring Cloud Config post as well. So look on our Okta YouTube channel and see if you can find that if you're interested. But you basically use a refresh scope, and then you configure Actuator to allow you to hit the refresh endpoint and refresh that configuration. But for now, in this demo, I'm just restarting, the registry and all the microservices so they pick up the new configuration. And we'll see if this is back up and running here. Looks like it is. The blog is down, and the gateway is down as well. So we'll want to wait till those are up and running. So now everything's up and running. You can see our blog, our gateway. We got a couple instances going, and the store is now working. So that's great. If we go to localhost 8080, we can confirm it. And we can sign in. It'll sign us into Okta. We can check out the store now, which has product entities. And maybe we'll add a new entity just to make sure, the communication with MongoDB is working. So we'll have a book, and it'll be $20. And we'll go ahead and take a picture here from our uploads, and we'll just use an Okta Dev logo there. Looks like there's an error. I'm not sure why that's not working, but, I had a problem starting up before, so... yeah, still got problems with store. So yeah, you can see the logs here. It's weird. It's saying that not master writing to the MongoDB. So maybe that's a clustered thing. Doesn't work on Minikube or whatnot, but the blog works just fine. So we'll go back to the blog, and you can see my data should still be in there. Yep, Matt's blog. So even though the store is not working, maybe that's something to do with clustered Mongo running locally in Minikube, and it works everywhere else. So, oh well, it'll work on Google Cloud. Pretty confident on that. So now I'm going to change Spring Cloud Config to use Git to store the information. So instead of storing it in source control like we have it, I'm going to actually do it on GitHub. And that will allow me to change the configuration without, redeploying, the Kubernetes configuration. So that's pretty slick. So in JHipster registry, we want to find the settings, not here, in this file. And we want to make that readable. And you can see here we have this native and this central config, the search locations. And so we're going to go ahead and add another search location. So this is composite 1. And we're going to have composite 0 is for the native and the file-based, and composite 1 is going to be Git-based, and it's going to go to this Reactive Java MS config GitHub repo, and it'll search in the config directory, and it'll use the main branch. So I have that checked out, and I will go ahead and go to dev, what do I call it? Reactive Java MS. And so in the config directory, and if I open that up, you'll see it has old information in there. So let me update that. We have all of these in this config map. So we can grab the issuer and the client ID. And we'll go ahead and save that and push it. All right, if you're going to do the same thing, of course, you would have to change this URL to match, your GitHub repo. And so now you can remove these values from this file, and you'll just have those stored in Git. And so now let's deploy it to Google Cloud. First, we will stop Minikube. Now we can exit out of there and exit out of our port forwarding. Now we will sign up for Google Cloud Platform. So this links to Ray Sang's site that he created on Spring Boot on Google Cloud Platform. That's GCP. The reason I link to this is because you can get started for free and receive $300 in credit. If you were to click on that, it shows you there. I'm just going to log into my console right here. And actually, I'm going to switch users. So my Gmail account rather than my Rabel design. So mrabel@gmail.com. And so now I'm in Google Cloud Platform, and I already have a JHipster 7 project created. So you might have to create a project. That's pretty easy. I just already had this one, so I figured why not use it. If you use the G-Cloud CLI, you can do all this locally. You can also do it right up here on Google Cloud with the Cloud Shell. If you were to do it on Cloud Shell, you would want to check in all your JHipster files, into GitHub and then clone them here so you have all those Kubernetes files that you could edit. I'm just going to do things locally here in my terminal. I'll go ahead and start with gcloud auth command. Oh, I got a typo in my instructions there. Gcloud. That'll take me here and continue using the Google Cloud SDK and two-factor authentication and click next and then allow it. And now my current project is set to JHipster 7, so that works for me. And I can enable containers and the container registry on Google Cloud. So that's what that command does. Finish successfully. And then I'm just going to use this as a scratch pad here. And I'll do reactive ms for the cluster name. Make sure you don't actually modify that file. And so this is very important. It's going to create it in the US Central 1A zone, but you can choose any zone you like. The machine type, though, what I noticed is if I go below this for a smaller machine, it doesn't actually start and run the JHipster microservices, so that's why I went ahead and used N1 standard 4. So while it's creating the cluster, we'll want to deploy our Docker containers up to Google Cloud Registry. So that's this command. It goes to gcr.io, our project ID, which will be JHipster 7, and the gateway, for instance. So we'll want to go into reactive JHipster here in the gateway directory, paste that in there, and change this to JHipster 7. If I can type. Come on, get those fingers rolling, Rabel. And we can do it for the blog as well and the store. So just make sure and change the application image name. And while that's happening, and we can go ahead and modify our deployment descriptors for these apps so it pulls from Google Container Registry instead of Docker Hub. So in the deployment files, right, there's one for blog deployment here. We'll go down to the containers, and you'll notice it says mrabel blog. So we're going to want to change that to gcr.io JHipster 7 as our prefix, and then we'll do that for the gateway as well, right here, and we'll do it for the store. Okay, so all of our Kubernetes files have been updated to look for the new containers. You can see the blog has finished here, and the store has finished. The gateway is still building, and our cluster is still building as well. So it's creating that cluster, it's doing Docker, it's uploading stuff, all kinds of bandwidth being used right now. So now our cluster has been created. We can go ahead and go into that KH directory with our deployment descriptors, and we can do the old kubectl apply -f, and that'll push everything up to Google Cloud. Obviously, that's going to take a while to start everything up, but we can use K9s again and look at our demo. And you'll see the JHipster registry is one to watch. And it's starting up much faster than it did locally, so that's the nice thing about using, cloud resources. Now we can get the IP address of the gateway. You'll see it's got that external IP right there. And then what we'll want to do, we can run Okta login to get the URL that we need to log in to our Okta tenant. And we'll go ahead and make it so it allows those redirect URIs for the gateway and the registry. So if we go into this K8's application now, we can edit its general settings, and we'll go out down here to the sign-in redirect URIs and add, the IP address 8080/login OAuth2 code OIDC, and copy that and do 8761, and then copy that and add it as the sign out one as well. And now if we save that, we should be able to go to that URL 8080 and actually log in. Pretty sweet, huh? I dig it. So back to our instructions. Now what we're going to want to do is add HTTPS to our reactive gateway. So we're using 8080. We want to use HTTPS. We don't want to have to type in the port number or anything like that. So this is just some commands you can use to actually get the external IP and open it. You can see what the HTML looks like. So I just went to my browser and it all worked, so maybe I got lucky. And now we'll create a static IP to assign to our gateway. So gcloud compute address says create gateway ingress IP. Okay, so that's created, and then we can make sure it worked. Okay, so now we have a static IP, and then we can create this ingress.yaml file. And so this will set it up so it routes, right to that 8080. Start by creating ingress.yml. And then we'll deploy it, make sure it worked. And the way you do that is kubectl get ingress gateway and make sure and specify the namespace. And then the address will show up right here once that is done. And you can just hit the up arrow to, keep checking. And it takes a bit. We've only been waiting 20 seconds, so we'll give it about a minute and see if it's running. All right, so I checked, several times during that break there, and 76 seconds it was done. So just a little bit of patience and you'll have that new address. And now what we want to do is have a TLS certificate for it. So if you have a real domain name, you can use that, but you can also use NIPIO. So if we were to open this up and check it out, it's a dead simple wildcard DNS for any IP address. So pretty handy service. And what we'll do is we'll just set that external IP to that new address. And then you'll notice if we echo the domain, it'll give us this right here. And then we curl it and it says 404 not quite found yet. So we do have to wait a bit for that to actually resolve. But in the meantime, we can just keep setting up the certificate and hopefully that'll be done. So to create a certificate, you'll want to create a certificate.yaml file. And so if you use this cat command, it'll actually take that domain, which is set as an environment variable, and put it in this file. So if you were to look at certificate YAML, you'll see it has that domain from nip.io in there. So if you were to manually create the file, just make sure and replace that domain, placeholder with what your domain is. And then we'll add this certificate to ingress. So if we open up that ingress YAML file, you can see it's got that global static IP name, and then we'll add this certificate, and then we can deploy both files using kubectl apply and -f for each of the files. Make sure and specify the demo namespace, and then we can check the certificate status using kubectl describe. So I'll just make sure and not grep it. And you can see it's coming back and the certificate status is provisioning. So you're going to want to wait until this one right here, the domain status says active. So while that's provisioning, let's go ahead and set up Spring Security and its Webflux implementation to redirect or force HTTPS. And so if you were to click on this link, it goes to Spring Security's documentation that shows there's like a redirect to HTTPS method that you can add to the HTTP class in your Spring Security configuration. And that'll work, but it'll redirect all traffic. And the Kubernetes health checks are using HTTP. So you don't actually want a 302 on those. You want it to be a 200. So what you can do is actually configure things so it only redirects when the exported proto header is present. And so that will only, it won't do those health checks. It'll just do your regular traffic. So if we were to open this up in IntelliJ, or we still have it open over here. So open that up, and then security configuration in the gateway, because the other ones we don't really need to do. I think you could do them and it wouldn't make a difference, but I'm just going to do the gateways configuration here. And so redirect to HTTPS when that exported proto is there. We'll save that, and then we'll rebuild the Docker image for this project. So we'll just do it in this gateway directory here. Project ID is JHipster7. Then we'll check on our provisioning. So it's still provisioning. It does take a little while, so be patient. Maybe do some push-ups, grab a Coke, get another cup of coffee, or go and read Twitter. The Docker image has been updated, and it's been pushed to Google Cloud. So now we can start a rolling restart of our gateway instances. And then once that is done, we can go ahead and use HTTPie, which you can get from httpie.org, maybe? httpie.io. Thank you for buying the .org, so it redirected me. And it's just a fancier version of curl, so if you have curl, you can probably do it as well. And let's see if this is done yet. Nope, still provisioning, so it's going on 6 minutes. We can do our domain thing up here. Okay, so we have that domain set as an environment variable, and we can try HTTP domain, and you'll see it is redirecting successfully, right? So it's forcing that HTTPS. We redeployed it, and it was pretty quick to start up, so that's all pretty awesome. And then the other thing we're going to need to do is update our OIDC app to take that domain into account. So this guy right here, we'll do that, and then add this suffix onto it, and then get rid of this, and then copy and paste this into Okta. We still have back here. Go ahead and add that redirect URI, and we'll add it down here as well, and save. And actually, we don't need this 8761 there, so I'm going to go ahead and delete it, because we can just use port forwarding if we need to get that one. And it's not actually exposed to the public by default, so no reason to have that in there. So now we should be able to open that domain up. So if we were to go to just nip.io, see if that certificate's all set up yet. Looks like it is. Let's make sure with this provisioning status here. So you can see status is active, so that's all working. And we have a valid certificate. It's running on HTTPS. If we were to sign in, everything should work since we set up those redirect URIs, and it does. We haven't actually looked at, communication with the database though, so let's create this book that we tried to locally that failed. And you'll see that's all working, talking to Mongo. And then if we wanted to do a new blog, we could create Matt's blog in production. And there we are. So we know our blog microservice is working. We know our store microservice is working. Let's look at encrypting secrets. So everything we've done so far is pretty much everything that we did locally, except we're running on HTTPS now. And we want to actually encrypt, the secrets that it's using for Kubernetes. So you might be familiar with Kubernetes secrets. Kubernetes secrets, let me show you an example here, aren't really that great. So if you're using them, don't think they're giving you good security at all. Let's look at this JHipster registry, for instance. And if you look at the top here, it's got the registry admin password. And the funny thing is, here it is, and then there's a comment that tells you what it actually is. So it's just a base 64 encrypted string. And if we were to, look for this guy down in the file, you'll see it's registered here or referred to here where it's like grabbing it from the secret. So it's just base 64 encoded. If you checked in these files and someone, does an online thing, like you can just, grab this and be like, base 64 decode. And you can go here and you can put it in here and decode it, and there's your password. So Kubernetes secrets aren't really great, but what is great is sealed secrets and Kubeseal. So I noticed this tweet from this guy, Daniel Bilar, and it links to a talk about the current state of secret management within Kubernetes. Go read the blog post that I wrote, and you can click on those links and see it and have a little more information. But basically, sealed secrets allows you to encrypt your secrets, store them in YAML files, and just like the Spring Cloud config encrypt key, everything will work nicely, and you don't have to worry about having actual base64, secrets in your code. So the first thing I'm going to do is install this sealed secrets CRD. So kubectl apply that. And then I'll go ahead and retrieve the certificate key pair that this controller generates. And so there's a TLS CRT here. See that? Grab that value. And then you can echo -n, paste the value, and then pipe it to base64, decode. And then we'll grab that value, the certificate itself, and we'll put it in a TLSCRT file. And then we can use the actual HTTPS certificate we have to encrypt, our data. So next, install Kubeseal, which I already have, but just in case I don't, I'll run that. And so it's already using the latest version there. And then the major item we need to encrypt is that encrypt key, right? We used to encrypt the OIDC client secret. So we can run the following command to do this, where the value comes from our JHipster registry file, not this registry admin, but you could certainly, encrypt that as well. We're just worried about this raw encrypt key that I put in here earlier. And we'll grab that, and need to modify this right here. And so that dumps it all into the secrets.yaml. And so you can see that's encrypted now. And you can use Kubeseal to convert the secrets to encrypted secrets. So Kubeseal -cert, point to that cert file, and format is YAML, namespace is that. And we're going to take that secrets and turn it into a sealed secrets. So if we cat that sealed secrets file, you can see it's got, that key encrypted now. And so we can remove our secrets file, and we can kubectl apply that sealed secrets and have, those actually stored up on our server, and, not worry about actually using Kubernetes secrets, which aren't really secret. And so now what we can do is we can change the JHipster registry from using, this raw value to using the encrypt key that we just set. And then we can kubectl apply it and roll out and restart all our deployments. Echo domain. And we can see if we can, access our gateway at least. Yay! So it's all working on Google Cloud. We got our microservices, our product. Should still have our product in there, yep. And we still got our blogs in there. So now everything's running with, that encrypt key being actual in sealed secrets. So that's pretty slick. You can also use external vault like HashiCorp Vault. And we have a post on that, Secure Secrets. Oh, I did it again. If you go there, you'll see from May of 2020, how to use Spring Cloud Config and Vault. And there's also a link here in my instructions on JHipster registry will soon have Vault support. So I don't know if that's been released yet, but that's pretty slick in that, you can use sealed secrets and store, everything safely in source control, or you can use HashiCorp Vault and have an external secret manager as well. And you can also scale, your replicas if you want. For instance, you can scale the store to have 2 different instances. And if you do that, one of the things that can be possible is that Spring Security, how we currently have it implemented in JHipster, has session-based storage where it stores, your access token and your OIDC token in the session. And so if you have multiple instances, it's not going to share that session. But the cool thing is you can do that with Spring Session and Redis. So you can make it so it shares that session. And we have this blog post that's probably not going to link to as well, but if you Google for Spring Session in Redis and JHipster, you'll find that blog post shows you how to configure everything. So Redis will, distribute your session between microservices. And then the last thing I would tell you to do is make sure and delete your cluster, because, this is costing me money right now just having this running. So you can do gcloud container clusters delete, and then your cluster name, which is Reactive MS for me, and then make sure and get that zone in there. And it'll prompt you if you want to continue. If you don't use kubectl get pods, you might have noticed I use K9s a lot. That's from my good friend Fernand Galliana. And there's a commercial version there too if you want to pay for it and, kick the guy back a little cash for all his hard work. Please do. And you can install it with brew install K9s, and then, use K9s demo like I did. You can find all the code for this on GitHub in the Java Microservices examples repo. And then, of course, the blog post, Kubernetes to the Cloud with Spring Boot and JHipster. So I hope you liked this screencast. It was a lot of fun to get everything working, and you see it wasn't too hard because JHipster really does a lot of the work for you. Follow me on Twitter. You can also follow my team on Twitter at Octadev. We also have a YouTube channel. Chances are you're watching this video on it right now. So if you're not subscribed, make sure and smash that subscribe button, and you'll get more videos like this one that'll make you more hip Java developers. Thanks for watching, and have an awesome day.